In today's note, we are going to look at expanding polynomials. So we have covered a little bit of this in review, but we're going to look at specifically expanding binomials. And the word FOIL is going to help us to remember how to expand two binomials. So basically two terms in a bracket multiplied by two more terms in another bracket. So if I look at this example here, or the word FOIL, FOIL is an acronym that stands for first, outside, inside, and last. So basically what that means is if I'm looking at my bracket here, or my two binomials, I'm going to multiply my two first numbers, so the x and the x. I'm then going to multiply my two last numbers, or my two outside numbers, right? So the x is on the outside, the b is on the outside. Inside, I'm going to multiply the two that are on the inside, and then I'm going to multiply my last, so the last two numbers in each binomial. So that's basically what FOIL means. Another way you can think of it is in like a rainbow method. So the first term has to be multiplied to everything in the second one, and then the second term also has to be multiplied to everything. So if I move on to an example here where I want to expand and simplify, we could do again the first, then the outside, then the inside, and the last. Or you could think of it as, okay, the x needs to multiply to both terms, the -1 needs to multiply to both terms as well. Either way you do it is fine. Just make sure you're multiplying everything that you should be. So I'm going to do the first, I'm going to follow the FOIL method just to make it a little bit easier. So the first two numbers, x times 3x, becomes 3x squared. Then the outside, so x times 2 is positive 2x. Then I move inside, so -1 times 3x is -3x. And then my last, -1 times 2 is -2. So again, make sure you're looking at the sign in front of each term to determine what sign it is, right? So you're multiplying by a -1, not a positive one. Next, what we have to do is we have to find any like terms. In this case, I can see my x's, I have like terms there. So 3x squared plus, or actually no, because 2x minus 3x is -1x, and then minus 2. And that is basically that product, or that multiplication, expanded and then simplified. For b, we're going to do the exact same thing. First, so d times d becomes d squared. Then our outside, let me just move this down a bit. Our outside, so d times 2, or positive 2d it becomes. Then we have our inside numbers, so -6 times d, -6d. And then our last numbers, so -6 times positive 2, which is -12. From there, now, I'm going to simplify my like terms. And if I can see, go back, that I do have two like terms of those, the values or the terms with d. So positive 2d minus 6d, or positive 2 minus 6, is minus 4d minus 12. And there we have our simplified expression. C, again, same idea. I'm going to multiply my first two terms. So 3a times 2a, 3 times 2 is 6, a times a is a squared. Then I'm going to multiply my outside terms. So 3a times -7b. So 3 times -7 is -21. A times b is just ab. So again, we can't simplify the a's and the b's together because they're not like terms, or they're not the same, they're not powers with the same base. So we just leave it as ab. 4b times 2a, 4 times 2 is positive 8. B times a, you could do ba, or you could just keep it as ab. Again, when you're multiplying, order doesn't really matter. And then lastly, 4b times negative 7b is negative 28b squared. Going through and looking at this, I should be able to see that I have two like terms. So 6a squared is going to stay the same. Negative 21ab plus 8ab, or negative 21 plus 8, is going to be negative 13. Then ab still stay the same, because when you're collecting like terms, you don't deal with the variables. And then minus 28b squared. So that doesn't change either, because there's no like term to that. D, x plus 3 squared. So here this looks a little different, but we have to recognize that the squared here means multiplied by itself. So x plus 3 squared can actually be written as x plus 3 times x plus 3. And now we can go through and expand using our FOIL method. So x times x, let me just use a different color here. X times x gives you x squared. X times 3 is positive 3x. 3 times x is 3x as well. And then 3 times 3 is positive 9. We can see that we have like terms, so I can add those together. X squared stays the same, plus 6x, or 3x plus 3x, and then plus 9. So there's my simplified term. Again, just going to go through more examples. So again, same idea as the last one. The squared means it's multiplied by itself, so I have to write it out twice. And now I can use my FOIL method to multiply through. So we should get 4x squared minus 10x minus 10x plus 25, because negative times a negative is positive. I see I have some like terms, so I'm going to collect those. Minus 20x and plus 25. Good. And that is expanded and then simplified. F is a little different. You can do it in a couple different ways. Because when you're multiplying numbers, order doesn't matter. So it doesn't matter if you do your two binomials first, similar to what we've done using FOIL, or if you multiply the 5 into the first bracket and then do your FOIL method after. Just keep in mind that 5 only would get multiplied to one of these brackets, depending on which order you do. You can't do 5 times all of these, because that's not how multiplication works, right? And it's not one entire bracket, it's two brackets. So that 5 is only going to get multiplied into one. So let's get rid of the 5 first. I'm going to multiply it into my first bracket. So I'm going to end up with 10x plus 5. And then I still have my last bracket, the x minus 3. And now I can FOIL because I have two binomials. Let me just move this down. So the 10 is going to get multiplied to both, and then the 5x as well. So 10x times x is 10x squared. 10x times negative 3 is negative 30x. 5 times x is positive 5x, and 5 times negative 3 is negative 15. You see that I have some like terms. So 10x squared. Then we have minus 25x minus 15. Again, because we're dealing with multiplication and then addition, and we have a lot of negatives in here, don't be afraid to use a calculator if you're unsure of your positive and negatives. I'd rather use a calculator to double check and be sure rather than just assume you know what you're doing if you're not very comfortable with it, or if you find that you've been getting mistakes in the past with the negative numbers. So again, just take your time, look at the sign in front, use a calculator if you have to. G, so G again, we have one bracket squared, so again we can rewrite this as 6x times 2x plus 1 times 2x plus 1. One thing to be aware of, if you were not going to expand this squared like we did here, you cannot multiply the 6 through and then square it. You still have to follow BEDMAS, so you either have to deal with that exponent first or rewrite it like this and then multiply that 6x through just to one bracket like we did in the last example. So I've already expanded it. I'm going to take the 6x and multiply it into the first bracket. So I get 12x squared plus 6x, and all of that is multiplied by 2x plus 1. So again, make sure you keep your brackets when you multiply through that, because it's everything that it's the product of what you just multiplied that's multiplied by that last bracket. Now I'm going to use my FOIL method or rainbow method to multiply or expand these two binomials. So 12x squared times 2x is 24x cubed. 12x times 12x squared is 12x squared. 6x times 2x is 12x squared. And then 6x times 1 is plus 6x. I do have some like terms again that I can collect. So 24x cubed plus 24x squared plus 6x. And there is our final solution, expanded and simplified. Lastly, again, one more example, same idea, just adding layers to it, making it a little bit more complex. Again, we can see a squared here, so I'm just going to rewrite this. X plus 2 times x plus 2, and then minus 3x times 2x minus 4. So I can do a couple of things. First, I'm going to multiply this 2 into the first bracket to help me with that before I can expand the two binomials. And secondly, in the last one, I'm going to take this minus 3x and multiply it through to that bracket. Because it's separated by a minus, or we have this minus here, they're separate terms, so we can deal with them separately at the same time. If you want to take your time and do that as a separate step on its own, you can. So 2 times x is 2x, 2 times 2 is 4. So that is all going to be multiplied by x plus 2. And then when we simplify the last, or expand the last, negative 3x times 2x is negative 6x squared, and negative 3 times negative 4 is positive 12, and then the x, so 12x. Now I can expand my binomials by using the FOIL or rainbow method. So 2x times x is 2x squared, 2x times 2 is positive 4x, 4x or 4 times x is positive 4x, 4 times 2 is 8, and then this last part here just gets added in, the minus 6x squared plus 12x. I can see I have some like terms with the x's as well as the x squareds. So I'm going to combine my x squareds. I should get minus 4x squared. Again, look to the sign in front. 4 plus 4 plus 12 is 20x. And then the plus 8, the constant, is on its own. So after all that, this is my simplified expression at the bottom. So FOIL is one way that you can use. It's kind of the most common way. You can also use a box method to help you expand binomials. And what the box method is here we have a box. I'm going to take one bracket or one binomial and put it on one side. I'm going to split it up and take the other and put it on the other side. So I have x and 2, x and 3. And each box is going to represent something similar to a multiplication table. So in this box here, x times x leaves me with x squared. The next box, 2 or x times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. So everything in the box tends to be, are all my solutions, or all my terms, sorry. So I'm going to write them all out. And now I can collect my like terms. I can see that I have x's together. So simplified, it's x squared plus 5x plus 6. And that's my simplified expression. In another example where it's a little bit different, it's not quite as simple, same idea. 3x minus 5, 2x, and then minus 7. In the first box, 2x times 3x, so 6x squared. In the second box, 2x times negative 5, or negative 10x, negative 21x, positive 35. So those are all my terms. So 6x squared minus 10x minus 21x plus 35. I can see that I have some like terms. So 6x squared minus 31x plus 35 is my simplified expression. And that is basically how you expand binomials. You can either use the FOIL method or you can use the box method, whichever you prefer. If you're using the box method though, you would have to simplify it down to 2 binomials before you can go into using it. So if you look at some of the examples where we had maybe extra terms, like if you see in G and F and H, you can't use the box method for those until you break it down into 2 binomials. Or another suggestion is you can use it for individual parts. Wherever you can see us foiling, you can replace with the box method and then take your answer and substitute that back in. So again, whichever way is preferable to you, you're more than welcome to do. I'd say just be careful with your positives and negatives and your signs, because that will probably be the biggest thing where you can kind of mix up your answers.